In this class, we will see about conics in mathematics. Okay, conics is a very important set of curves. Okay, we will see what is set of curves in mathematics. What it means is simple. In a simple language, what a conics is, you know a cone. Am I right? You all know a cone. So what's a cone? This is a cone, you know. Okay. Now you intersect a cone, cut a cone with a plane. What all the ways you can cut? You can cut like this, diagonally, all possible ways. So once you cut the cone, you will get the intersection will be some curve. If you cut parallel to the base, you'll get a circle, or tilted, you get a ellipse. Okay, all those things. Okay, and if you cut a plane along the tangent, then you get a straight line. If the plane is tangent to the cone, it will be a straight line. Okay, so why this is important is, so this conics, so all the family of curves, all possible curves, you can get by intersecting a cone and a plane is called as your conics. Okay, and why this conics is important is, in most of our lifetime, whatever the curves we are seeing, all the curvatures, they can be, under some cases, most of the cases, under some small region or something, they all can be represented by one of these curves. So this gives you the basic set of curves. Okay, for example, what are the curves you studied till now? Straight line. Straight line is also one. Okay, straight line is a curve. Okay, straight line, circle. Only till now you read about only straight line and circle. Now you see when you throw a stone, projectile motion, that's a curve. That you will see, if you remember, you said that's a parabola. You will see what's a parabola. Okay, all this, all the curves, what you see in your day-to-day life, orbit of a planet around a sun. Okay, all these orbits, all these curves, they all belong to a single family, what you call as conics. That is what, when you cut a plane, when you cut a cone with a plane, the curve you are going to get. Okay, so that's what we call it. So before let us go into detail. Let us see how we are going to draw a cone. First thing is, we have to draw a cone. Okay, so how am I going to draw a cone? Let me have a straight line. Oops, sorry, it's not straight. Let us draw a straight line. Okay, and let me take a point. Let us call the straight line as, say, something like your in your book what they given, L, right? L is a straight line. Okay, and let there be a point, I call it as V. Now let me draw another straight line passing through the point V and making an angle. Oops. Okay. So let it pass through the point V, making an angle, let us say the angle B, alpha. Now if I ask you, how many such lines you can draw? How many such lines you can draw? The line should pass through the point V and should make an angle alpha.
360 by alpha.
Only how many lines you can draw? You can write infinite lines, na?
Oh, like that.
Alright, because you have to make all possible lines.
Like in a cone way.
Yes, of course. So the surface formed by all the lines, the infinite lines, we are going to spin it around this axis. This is the fixed line. You make it all possible lines. That surface is called as your cone. Okay, they return a right circular cone, but right circular cone need a base anyway. So what we have, so when I draw that, you can actually get a surface. Okay, so this surface, this surface don't stop, it's extend, it's a cone, complete cone. You got it? So this is what your cone is. So now you tell, I said as a conics means what? You are going to intersect this cone with a plane. Am I right? There are many ways I can cut the plane. First thing, let us try to see how I am going to cut the plane. So let us cut the plane. Let us choose a plane which is maybe we call this as, okay, what they call is, okay, this is what we call as your This is your vertex. This is your axis. Okay, that's your line L, and let us call this line as M, and this is your generator. Why it's generator? Because that's what's generating the cone, the generator. Okay, now you tell me, so if I take a plane which is maybe perpendicular to the axis, what you're going to get? Intersection will be a circle. So you can get all the things. Okay, in fact, circle is a special form of ellipse, you will see that. Okay, suppose if I tilt it, you're going to get an ellipse. Okay, you'll get an ellipse. Okay, so now, so I'm having a plane like this, you get a circle. I tilt it, you get an ellipse. I keep on tilting. At some point, the plane is going to be parallel to the tangent line. You got it? At that time, will you get an ellipse?
No.
It will be a curve, it won't be a closed. Okay, it will be open curve. Okay, that curve is called as a parabola. Sorry, that is a parabola. Okay, so what happened? How am I going to do? I have the plane. I am going to tilt the plane slowly. At one point, it becomes parallel to the generator line. Then it's not going to get a closed curve. It will become open curve. Correct? That curve is called as a parabola. Now I tilt further. If the moment I tilt further, what am I going to get? It will be open curve. This line will cut this cone also. You got it? Till now, the plane is going to cut only this cone. The moment I tilt it further, this line is going to cut this cone as well as the opposite side cone. So then you get two set of curves. Till now you get only one curve. So what happened? First you got a ellipse like this, and then slowly it becomes like a parabola. Okay, when I become parallel to it. So when I tilt it further, then you are going to get two curves like this. Am I right? One here and one here. So this is an ellipse. And this is your parabola. And this is your hyperbola. Okay, and this is what? And now, suppose, think of, this is not only curve. I said even you can produce lines or straight line also can be produced in one. Suppose if a plane is parallel to the axis, parallel to the axis I am saying, possible axis. So it cuts, what you will get? Two intersecting lines. You got it? You just get two intersecting lines. Because I am cutting the cone like this. So you get two intersecting lines. So these are all the possible curves. So if you see all the curves, whatever you have seen, studied till now, they all fall under this category. So that's why the conics topic is important. Okay. So, there are some, they written this is a double cone. They written as double cone. Okay. The point V is called as vertex. Okay. So, yeah, what they call this, the surface, when they call it double napped right circular cone. Okay, fine. So there are conic sections. What they given is a plane is perpendicular to the axis, not plane. A plane perpendicular to the axis and does not contain the vertex. It will create what? Circle. That's what it written. A plane parallel to one position of the generator. Okay. But does not pass through the vertex. We get a parabola. I said na? We get a parabola. A plane oblique to the axis and not parallel oblique to the axis. And not parallel, less than parallel to the generator. What you get? You'll get an ellipse. Correct? So in that case, when the oblique to the that's what a double cone is cut by a plane parallel to the axis.
Double cone is cut means that.
A plane parallel to the axis, which we get parts of curve. Okay, it is not necessary to be parallel actually. What a book they written is you have to be parallel to the. Okay, if you're parallel to the generator, you get a parabola. Am I right? So if it's parallel to the axis, then you get a hyperbola. You got it, but it's not necessary. You should have a system of two curves. You can represent by a hyperbola. Okay, So but anyway, in your book they are written it should be parallel to the axis. So maintain the same. Okay, and this one, the last one, a plane containing a generator and tangent to the cone. I mean the same thing. What is intersecting line? That gives you two intersecting straight lines. That's what. Okay, so this is what you call as your conics. This all the set of curves, whatever you can form, this is what we call as a conics. Okay, now even a point can also be a conic. How? Take a plane passing through the vertex. It will be a single point. Am I right? So, right. So this is all. This is what we call as your conics. And now, so now this is just a definition. Okay. Now in mathematics or in geometry, when we define a curve, what we do is we define a locus of point. A locus. You got it? So every curve, you remember, a straight line has a locus equation. Circle had an equation. What is the locus? The locus is the set of points which satisfy a certain condition. Correct? That's what we saw. Okay, so if you remember, we had a point. So we had something like this. What you have, let us say L. It's all basically sets. So P, they put a straight line, not a, sometimes they write a column there. P is a point satisfying y equal to 4x plus 2. Can you tell me what is the locus of this point?
A straight line.
It's a straight line, correct? P is a point satisfying x square plus y square equal to 4. It's a circle. Okay, so this is also in geometry, all these curves we have to define as a locus of points. Similarly, when we say conics, we got different curves. So they also has to be defined. So conics has to be defined as a locus. That means a set of points which satisfy certain condition. Okay. So what you will see is when you do that, so you will see all the curves of the conics. That's what circle, ellipse, parabola, hyperbola, all these curves can be defined as a in the terms of locus is. So let there be a line L. Okay, so the conics is nothing but, okay, so let us have, this is the point P, whose locus is the conics. So the conics is such that you have a straight line, say something like D, okay, and I have another fixed point, say something S. This is a fixed point. So, and this is the locus point we are saying. Okay, so let the distance between this point B, so let us call this as say something OP. Or not O, let us call what in the book they are given. O, they are using it for the axis. So, M, yeah, let us do it as M. M, P and S, yeah. Okay, so now what conics is, if you can, all the curves, all the set of points P which satisfy the condition P, the distance between a fixed point S, that is PS, and the distance from a fixed line D, that is what PM. Okay, so the ratio PS by PM should be always equal to constant. You understood what I am saying? Okay. So if you remember, in the circle also we got a similar thing. What is a circle? When you write a circle, circle is the locus of point which is equidistant from another point.
The radius.
Am I right? That's a radius. Correct. Circle is a set of locus of points, set of point which is equal distance from another point, and you call that point as center, and the distance as a radius. The same way, when you come to conics, what it says is this conics is a set of points whose distance from another point and another line, the distance ratio has to be always constant. Okay, and incidentally, once you define this, you can define all your conics with this, all curves. Even circle comes under this condition. Okay, the moment what happens, you bring the both the points together. So then all the points will be same. You got it? So that way you can, it means you may, not really. So if you want to make it a straight line, okay, circle we will see. When you do the ellipse, we will see how the ellipse will eventually become a circle. Okay, so we can see. So this is what your conics. Okay. So this is what. So then we can. What are the quantities required for finding the equation locus of conics?
So first,
D.
distance from
The straight line is required,
straight line.
and a point. These 2 points are required. Got it? So then you call this this point S is called as your focus, and the straight line is called as your directrix. Director spelling R-I-X. D-I-R-E-C. Where is that? D-R-E-C-T-R-I-C. R-I-C. Directrix. Okay. So this is what your conics equation is. Okay. Fine. So then they have a set of we will find out the equations. Okay. So then what it says is, the conic says is, your PS by PM has to be equal. Okay, that's a constant. So let us call that constant as, so PS by PM, we are going to call it as E, where E is a constant number. Depending upon what the value of E is, you will get different forms of cone circles. That's the beauty of this locus. Choose your E. What value you are going to choose for E? And that E will give rise to your ellipse, circle, parabola, hyperbola. Everything is defined by only one quantity. That's a E. Okay. So now, and we will see that as we go along from the equations when you draw, we will see how this constant is going to define your different family of curves. Okay. And now, fine. And this E is called as your eccentricity. Eccentricity. Spelling? Yeah. E-C-C-E-N-T-R-I-C-I-T-Y. Eccentricity. Okay. So now from here we can write your PS is equal to eccentricity into PM. So this is what you called as your focus directrix relation. Okay, and this focus directrix relation is the one which actually a property, what they call focus directrix property. The written as a property. Okay, so this property, the whole property is decided by only one quantity. What is that? E. So now from here itself we can say E can be equal to 1, E can be greater than 1, E can be less than 1. So what will you see is, by that choice, when E is equal to 1, when E equal to, you get ellipse. Circle is a special form of ellipse.
But no, if E is equal to 1, then the distance of PS and PM will be equal, right?
Why?
Because PS by PM is equal to E. So if E equal to 1,
Yeah.
that should be what?
So remember, as the point moves, suppose if I keep the point here, okay, what it says is this distance and this distance should be equal. You got it? Don't try to take about, that's what even mistake I was trying to do. We are not taking this distance. Okay, we are saying from this point P, these two distance has to be equal. Suppose if it is here, the point will be here. Because this distance and this distance will be equal. That's when E is equal to 1. If E is not equal to 1, this is not going to be equal. If the ratio is 2, then it's going to be different. If the ratio is going to be 0.5, then it's going to be different. So this decides all curves. Okay, we will see that. Okay, so you got it? You got the answer? So, okay, then let me read some of the useful terms in the conic section. Okay, what they say is, oh, okay, no, I have to define. Yeah, so then after defining, so then you have the three properties. What are the three properties you have? E is equal to 1. E should be positive. 0, E is greater than 0, less than 1, and E is greater than 1. Okay, so depending upon these three properties, when E is equal to 1, what you get is your parabola. Parabola is what? When you cut the conics with the plane parallel to the generator line. Okay, this is a parabola. In this case, what will you get is your ellipse. This will be equal to cutting a plane with an angle, now means not parallel to that direction, because that angle tilted. Okay, so and when E is greater than 1, what you get is your hyperbola. This always produce a pair of curves, two curves. Okay, you got it? So this is what the thing. So and now they have some definitions, some useful terms of conic sections. Axis. Okay, the axis is nothing. Axis is you are having one fixed point focus. So you can draw a line perpendicular to your directrix passing through S. You understand the point? So this is, remember, for us, let me make it a circle. This is the locus point. So the point of the circle is the one which is going to move. These 2 points are fixed. This line is fixed, this S is fixed. So now these are fixed basically. So you can always draw a line which passes through S and perpendicular to D. Am I right? So let me draw that line. So that is what this line. Correct? This you call as axis. Okay, what they say? The line about which a conic section is symmetric is called an axis of the conic section. Well, this is a line. You will realize in the next class when I say, I will show the around this line the conic will be symmetric. If it is a parabola, they both will have the same shape. If it is a circle, they will have an equal, symmetric. Symmetric means the same. You cut it and place it here, or you cut it and place it here, you are not able to differentiate. They both will be exactly same. You got a symmetric means you know what is symmetric, right? Yeah, fine. Then the vertex. The point of intersection of a conic section with its axis of symmetry is called as a vertex. This point. So now what happened? I told you, if it is a parabola, they both E is equal to 1. Am I right? So that means this both the lines should be equal to 1, because that when E equal to 1, PS equal to PM. So that means PS equal to PM. So now we put all the points starting from here. You got it? So let me draw it with a dotted line, something like this. So all these points will have the property this and this are equal. All these points will have a property this line and this line are equal, because E is equal to 1. Okay. So now this intersects your axis at some point. So that is called as your, let us call it as O. That is called as your vertex. Okay. The point of intersection of a conic section with its axis of symmetry is called as your vertex. Focal distance. The distance of a point on a conic section from the focus is called the focal distance of the point. I am not sure about it. Yeah, okay, yeah, fine. Yeah. So what is it? Take a, take a point on the conic. This distance from the focus. So this distance is called as your focal length, focal distance. You got it? Any point on the conic and the distance from that point to the focus is your focus distance, focal distance. If it is a circle, that is going to be around this S is going to be always constant. Okay. Well, focal chord, the chord of a conic section passing through its focus is called the focal chord. It's basically what? A line which passes through this conic section, this one. Not vertical, it can't be anything, it has to pass through the focus, that's it. See, a chord of a conic section passing through its focus is called as a focal chord. Then comes a lattice rectum. a focal chord of a conic section which is perpendicular to the axis of symmetry is called as your lattice rectum. That's what, this is all the focal chord. Now there will be one focal chord which is perpendicular to the axis. Let me draw it like this. So this focal chord is called as your lattice rectum. What is the name? Lattice rectum. You got it? Fine. And then the center of a conic, the point which bisects every chord of a conic passing through it, is called as the center of the conic. Tell me, what is that? A point which bisects every chord.
Every chord will pass through it.
Every chord passing through it. Correct. Okay. So you draw all the chords. The point which bisects it, that's you called as your center of the conic. Then the last one is a double ordinate. A chord passing through any point on the conic. Okay, this is what lattice rectum, correct? Now you take a chord passing through any point on the conic and perpendicular to the axis. You got it? So that's what you called as your double ordinate. Okay, so this is all the definition, means this is all the some useful terms in the conic sections. Okay, so now, so we will see about, so what we saw today in this class, we saw about the conics, what are different part and different terms, or what do we mean by conics? This is a set of family of curves we can form by intersecting a cone with a plane. Okay, that's the one thing we saw. And the next thing what we saw is, what is that? Then we found the locus of a cone. Okay, locus of a conics. And that we will see. As we go along, we see this is the condition. So by this condition, you can form all the conics curve. So all you have to remember is you have to define a fixed point and a fixed straight line. And now any point which satisfies such that the ratio of the distance between the fixed point and the fixed straight line, if it is a constant, then all that curves, all that locus of point is going to define your entire conic section. Okay, conics curves. So now, incidentally, you will see when that ratio is equal, it becomes a parabola. We will see those things. When the is less than 1, it becomes an ellipse. When it's greater than 1, it becomes a hyperbola. So this defines your entire conics curve. And why this is beauty is, these are the 3 curves which almost define all your trajectories and path and everything. Take about from your normal any circular motion, okay, your fan or whatever, you throw a stone from there to planetary orbits. All the orbits, everything is defined by this set of curves. That's why this conic section is important. Okay, so in the next class, we will see about how to get the equation of first we will go one by one. When E equal to 1, we will see, get a parabola, and let us see how we are going to get the equation of a parabola. Okay.